Okay, so we've got some good weather today, a little bit windy, so I won't be tuning, but weather is good enough to do some additional configuration. And if you remember in the previous video, I'd got tuning working well, PosHold worked well, hold worked well, so now, given that I've got sort of GPS things working correctly, I'm now going to sort of move on to RTL and some of the fail-safes. So the first thing I'm going to do is set up RTL on a switch, and I'm going to use the switch that I used for auto tune. So this is RC8. So I'm going to set this to 4, which is RTL. So RC8 is my RTL option. And then I'm also going to change the RTL altitude. So by default this is 15 meters, and I find that a little low because of trees. Nothing worse than hitting RTL and the thing flying into a tree. So I find 20 meters suits me a bit better, and I think that will work well. RTL alt final is 0, which means land. And then the other thing I'm going to do is set up the throttle failsafe. Which is FS throttle enable. And that's currently, I remember I set that to land. Now I'm going to set it to 1, which is the default, which is to RTL. So I'm going to test RTL. I'm then going to test the throttle failsafe with RTL, assuming that goes successfully. The thing to bear in mind with all of these is you've got to be ready to switch mode to stabilize and take control, just in case something goes wrong. So that's what I should be doing. And then the other thing I'm going to do is just check the Propwash, stability in Propwash. So I'll fly the copter a little bit and sort of throw it up and then let it come down in its own Propwash and see how that goes. And we're looking for good stability in Propwash. I'm pretty confident that with the harmonic notch set up that will be fine, but we'll see how that goes. Okay, so this is the first test.
Okay, so this is a return to home, return to launch test. So it's hovering in PosHold, a few meters away from me. And what I'm going to do is switch to return to hold. There we go. It should go up in the air. 20 meters up, which is what I configured. Center on the landing pad. And then come down on the landing pad. That's pretty good. I'll stop there. And that worked pretty well. The reason I switched back to PosHold was this is only an M8 GPS small puck, so it's not going to come down. My landing pad's less than 1 meter square, and so it's not going to come down precisely on it. So as long as it's within sort of 2 meters, I'm quite happy with that, and it was. But I don't want to land in the grass and start chopping grass with my props. So that's a good test. And next up is the more scary radio failsafe. So I'm gonna, now I know return to home works well, I'm gonna try radio failsafe. Okay, so this is the same test as before, except this is a bit more scary. So I've got the copter hovering nicely, and now I'm going to power off the transmitter.
Receiver still connected.
Transmitter's powered off, copter goes up, and then should come to home. Then I'm going to power on the transmitter again. There we go, and the land it's
GPS 3D log. Stabilize flight mode. Landing complete.
successful test, apart from my flying with my middle finger on the control sticks. So a successful test, switched successfully to RTL when the radio failsafe triggered, and was able to recover the radio failsafe. So I feel comfortable about going a bit further out now.
And it's worth remembering that I didn't do that transmitter failure test straight off the bat. I'd already verified on the ground that I got an RC failsafe event when I turned it off. So I was fairly well prepared. Nonetheless, I always find that pretty scary doing that test. You just wonder whether the thing's going to fly away.
And I wasn't able to show you that test. I need a cameraman for that test. So basically what I was doing was I was switching the copter into stabilised mode, taking it up fairly high, and then really cutting the throttle so that it just comes down fast through its own prop wash. And I'm looking for instability there, and it looked very, very stable to me. And I have to say, given the size and weight of this thing, it's remarkably agile, and when I gun the throttle straight up, the thing goes like a rocket, so that's pretty pleasing. So I did that a few times, and just sort of to check. I don't have air mode set, so I don't have any control when I let the thing fall. So that's something I'll do in the future when I start tuning for acro, but for now testing for prop wash in stabilised mode is good enough, and I was pleased with that test. I'm going to do a final test now where I basically hover for a fixed period in PosHold. I've got the logs, the FFT logs turned on to get pre-filter logging, because I just want to see what kind of noise with this tune, what kind of noise is going into the aircraft. I'm expecting pretty good results because I've seen the other side. The post-filter tune looks very good, but I'm just going to get that data. So the post-hold has been pretty good. A little bit of altitude drift, which I'll have to investigate, but in general it's pretty good. It's quite windy today, so you can see the wind there, you can see the altitude drift a little bit there. In general it's pretty good. So I think that's probably enough data so I'm going to land and go home. So I've landed now. Just one other test I like to do just after a sort of hover like that is to check the motor temperature. And often the bell won't give you the motor temperature because of conduction. You want to really feel the stator if you can. Nice. These motors have these sort of reduced size bells. They're sort of cut away to save weight, and so you can actually touch the stator with your fingers, and those are dead cool, so no heat at all coming out of those motors, which is very nice. So I'm really pleased about that. Looks like things are working pretty well.
I probably should say thank you, Andy, at that point. So it's worth remembering with the testing the motor temperatures, although I was doing that after a fairly long hover, I'd also done that at various points during the initial tune, and early on it's really important to check for motor temperatures, because if you've got a bad noisy tune, your motors can heat up and smoke in a matter of seconds, 30 seconds maybe. So early on you want to sort of hover for maybe 10 seconds test the motor temperature and check you're not getting any heat through, because it's a good way to smoke motors. Okay, so that was my outing, and brought the copter back, and I'm now going to download the log file and just do a little bit of analysis on the log file. Okay, so I've opened up the log file in Mission Planner, and I downloaded it in the usual way. So it was a very large log file, 137 megabytes. And if I switch on, if I have a look first at the throttle, you can see that this is basically a single log for all of my tests. And you see arm disarm events here. So I don't really like logs organized that way. I like logs being rotating after each arm. And so what I've done is I've set this parameter log file DSR mrot, really what a mouthful, to 1. So that basically means rotate the log file each time you disarm, and then you get a nice clean log for each flight rather than this 137 megabyte monster. And here you can see the various hovers that I did. If I add the altitude in, you can see, so here this was the first test. It goes up to 20 meters, which is great. And I must have done another hover in the middle there. I think this is the second test. Again, goes up to 20 meters, comes down again. And then this is when I was throwing the copter up looking for Propwash. And so I'm going to just look at this section of the graph a little bit more. So I'm going to just to see what the vibration levels look like. So what I'm going to do is I'm going to switch off the altitude. I'm going to go to rate, and this basically shows what, oops, not RC out, to rate. This shows what the log, it shows what's going, what the PID loops are sort of commanding, and the key ones, the useful ones, are these out values. So for instance, if I look at this is roll, and roll, desired roll, so that just basically sort of looks at how good your tune is. And so for instance, if I look at this part here of the log, that's not great, is it? Clear the graph, let me clear the graph, roll, and then desired roll, and then let's look at this bit. Well, so what you want to see is things following closely, and that doesn't look great to me, so I might have to tune it a bit more. There's also ATT, which gives you a slightly different view of the same information. So for instance here, let's scale out again. Difficult to see, where's the throttle? Okay, so this is the noisy one. So if I look at this one, which is the non-noisy bit. Okay, so you can see roll is following quite well there. Not following so well in this Propwash bit. And if I look at the rate, then the key thing here is this R out. Let's clear the graph again. Let's go for throttle, just so I know where we are, and then R out. And what we're looking for, so this is R out, this is the scale on the, this is a percentage. And so what we're looking for is a sort of absence of vibration. So you can see there's an oscillation here. And what we want is this oscillation to be below 10%. So 10% is 0.1. So you can see that's at about 5%, maybe a bit less, sort of around the middle. So that's okay. Similarly with pitch. So pitch again, so here's 0.1 is about here. So pitch again is about 5%, which again is fine. And then your is similar, so again low. And the one I'm interested in is here, where we were kind of doing these Propwash values. I'm just sort of interested in what level of noise is coming through. So you can see pitch is a bit noisy here, perhaps noisier than the other ones, but it's still generally below the 10%, so I'm reasonably happy with that. So it will probably tune it a little bit more, but at the moment it's looking pretty good. And then the other thing to check is, which I didn't show in a previous video. Let's go back to throttle here. Oops. Yeah, there we go. Throttle is to look at the vibes, and this is per IMU. So this is 5 to 15, which is okay. I guess you want X and Y to be under 15. So I've noticed this. So Y is a bit higher. It's sort of peaking at 30, which is manageable, but it's a bit higher than I'd like. I prefer it down at sort of 15 level. And then Z is again quite low at 15. Interestingly, I think on the other IMU, again that's 15. No, it's up around 30. So there's more vibration front to back than any other axis, which I'm not sure. Sometimes with these things, it's because maybe you get knocking on the front or the side of the flight controller, and that's sort of the vibration that you see. But I've checked it quite carefully, and it doesn't look like that's going on. And similarly, clip. You see, we're getting some clipping events here. Not a gradual increase, but you see we got some clipping around the throwing up bit. If I take that out and put this on the other side, clipping events. So you can see that we get a few clipping events. So I don't know, tens. It's not too bad. The flight controller is fairly hard mounted with some gummies. We get a few more clipping events around this region, which we would expect, but we have to see when I start flying it hard, see what that looks like. So flying hard in manual, I'm not too concerned about clipping events, but it does mean the UKF can get a bit unhappy. So we'll have to see what happens when we fly that hard. I'm hoping I'm not going to have to remount anything, but yeah, something to watch. Interestingly, the other IMU, no clipping events. So I think one of these, I can't remember which is which here, but one of them must have a higher accelerometer range than the other. So no, I would guess that this clipped one is the MPU 6000, which is an older chip and has a lower accel range. And I guess this is I think it's a ICM 20602, which I guess has a higher range. Okay, so that's what I wanted to sort of check vibration wise. That looks okay. The other thing I was interested in was just this, so this hover at the end. so the altitude. So here's the altitude. So the altitude, according to the EKF, was stationary. I'm just interested in what the baro and the GPS made of it. So the baro or altitude was going up and down. Oops. The GPS altitude was going up and down. So I'm not quite sure why this was. So baro and GPS were kind of showing what was actually happening, but the EKF seemed to think the altitude was steady, which it wasn't. So I don't know quite why that is, but it wasn't significant. So I'm not worried by it, but I will investigate that at some point. So the other thing I want to do is do an FFT on the graph. So I have FFT logging enabled, and so in this one, you can see here that FFT logging is enabled via this log bat opt. I've set to 1, and then I've set bat mask to 3, which means both IMUs. So this is a bit mask, and I think that's the only things I have to check. The other thing is that I've got this bit mask that has most of the logging on because I've got quite a nice fast SD card. So this allows me to get a good amount of logging. So what I don't have on is fast IMU logging because I'm doing this other kind. Usually to get the FFT graph, I think there's in one of these there's setup, optional hardware, FFT. So there's an FFT. Okay, so that's right. So there's a little button here that you can press to do an FFT graph, and it looks, if you have to open up the graph again, and it looks like this. So this is actually a pre-filter graph. So there's a number of software filters on the aircraft. And this is what the noise looks like going into the filters. So it's the raw data coming from the IMUs. Oops, don't really want to make that bigger. So what I'm interested in is the gyro noise. And you can see there's a big spike at 130 odd hertz, which is the prop RPM. And not much else going on. And that's good. And that means the tune is, what you can see is this sort of feedback noise where these sort of bump up, you get more noise in sort of upper harmonics, but I'm not seeing that. So that looks pretty good. And then I can sort of look at the post FFT log another time, but it's just good to see sort of what noise data is going in there. Okay, so that's the end of that bit of the tuning. I'm pretty pleased with how the tune is. Things are looking good. I'm confident that if I have some sort of event that I'm not going to lose the aircraft. So really the next thing to do is take it out to a bigger area and do some hard flying and see how it performs and see what the noise looks like, especially at low and high throttle. And then when I'm happy with that in stabilize, then what I'll do is configure some acro parameters so I can fly around a bit more aggressively in acro. And that should be fun, but I need good weather for that. So hopefully this weekend we'll see.